Hello everybody and welcome to today's video on AI model, specifically in the context of machine learning. So let's get right into it. So first of what is an AI model? So there is this formula that I came up with to simplify your understanding of what an AI model is. So this is it. Training data plus an algorithm equals to model. So training data plus the algorithm equals to the model. So the model is the result or the end product of applying the algorithm to the training data. What is an algorithm? An algorithm is basically a step-by-step instructions on how to achieve a task or solve a problem. And a model is the result of it. So for example, let's say a model, we want to create an image classification model. That's the model. The algorithm would be CNN, convolutional neural network. And then our training data is the data used to train the model. So now let's break this even further. And so you already got the definition of algorithm. I don't think I need to write that out. So now let's break this down and say what are the types of data, where I would even explain what a training data is more elaborately. Types of data. We have the training data, we have the validation data, and the test data. So what is a training data? A training data is a collection or the subset of, so let me visualize this for you. So this is your data in total. Industry standard is more like using about 60% of the entire data you have to train, and then 20% for validation, 20% for tests. So this is the proportion of your training data. This is the proportion of your validation data. And this is the proportion of your test data. So training data, let's just put this as data samples, data samples, data samples, data samples, data samples, like that, just to visualize it. So a training data is a collection of the data that is used to train the algorithm to get a model, to get this model. Training data is a collection of data used during the training process to train the algorithm. Because remember, training data plus algorithm helps you develop a model. Now, what is a validation data? It's almost intuitive, as the name is validation. So validation data is the collection of data that is used to assess the model's performance during the training process and where necessary to fine-tune the model. Fine-tuning the model means to adjust the parameters and the hyperparameters where necessary. So parameters and hyperparameters, to simply put, just is see it as bolts. When you're trying to adjust the bolts of maybe a car engine or something, that's what the parameters are. You use it to tune the frequencies of the model better so that it's able to perform well and achieve the goal with which you created it for. And the test data, see it as an exam or a test. It's given once, number one, and it's given at the end of the entire training and validation process. So once the model has been trained and validated, then it is shown this test data just once, and that test data is meant to be a similitude of the kind of data the model will see in the real world. So the performance of the model with or on the test data is crucial, and it gives us an idea of how our model will perform in the real world. So in machine learning, there is this tension, or you could say dilemma, between two ideas or concepts called optimization and generalization. Now, what are these? What is optimization and what is generalization? So now let me tie this in the concept optimization. I'm going to tie this to training data. So, we train our model first on the training data. Optimization's goal is to ensure that our model performs well on the training data. So, optimization ensures or refers to how well the model performs on the training data. Now, generalization, on the other hand, refers to how well the model performs on never before I don't know if you can see that, but let me just write that in the next line. Or never before seen data, or we could just say or never seen data. Basically, data it has not seen before. That's what generalization means. So in machine learning, training a model, there's always this tension between optimization and generalization. It's like the goal is that actually the real goal is to ensure that your model generalizes well to never seen data. That's to test the outside real world data. But we can't really control this. Just the way in life, you can't control things that are outside of your purview, outside of your abilities as a human being. You only can do what you can do, and you leave the rest to God. So optimization, we can control how well the model fits to the training data, but we can't control how well it performs on never seen data. Now, the thing is, for this optimization, which we can control, if we then fit it too well to the data, fit the model too well to the data. Fitting the model too well means ensuring that the model learns the data so well so that optimization is good. If we do this too well or too much, generalization suffers. And so let me write this down. So if this is too much, this leads to overfitting, a phenomenon called overfitting. And then because the model has learned too much about the training data, it's not able to perform on whether never seen data before. So stay with me. I'll explain the concept of overfitting and underfitting well later on. So now let's even just go there and explain what overfitting is. So the concept of overfitting and underfitting. I thought I took another color. Let's explain that now. Overfitting under what is underfitting? Underfitting, let's start with underfitting. Underfitting occurs when our model doesn't learn the relevant patterns or underlying patterns in the training data. So that means it doesn't optimize well. So where model does not learn the relevant patterns in the training data. Now, what is overfitting on the other hand? Overfitting is the flip side of underfitting, when the model learns too specific details in the training data that are irrelevant or unimportant to its generalization ability. So the model learns too specific details about the training data that are irrelevant. Yeah, in this case, we call it noise. It's learning noise. And overfitting and underfitting. So now overfitting leads to high variance. That's noise. And then underfitting leads to high bias. So variance basically means where the, do I write it? Let me just say it. So variance basically means that this is it's a type of error that occurs when the the model is too complex for the simplicity of the data. That is, it learns too specific detail. It has too much noise in it that it's not even able to generalize well. And high bias, on the other hand, is a type of error that occurs when the model is too simple for the complexity of the data. That means it does not learn relevant patterns in the training data that can help it to be a good model, which also leads to not optimizing well. And finally, there's one more thing I want to talk about, which is evaluating a model. So evaluating a model depends on the type of model, the problem it's solving, its objectives, because that will determine the type of evaluation metrics we will use. So for example, if it is a classification model, sample classification models use metrics such as accuracy, precision, recall, F1 score, so if you want to know more about this, evaluating a classification model, I've dedicated a video coming out next week that talks about classification models, how to understand this evaluation metrics, and also visualize the model's performance using a table called confusion matrix. So if another type of model we could look into is what is called regression models. Which uses metrics such as mean, square, error, which is also known as MSE, and mean absolute error, which is known as MAV. I hope you can see this. All right, so that brings us to the end of this video. Let me know if you have any questions in the comment section. And also, do not forget to pre-order my book titled AI, Machine Learning, Deep Learning from Novice to Pro. It's available on Amazon. You can find the link in the description below and or in the pinned comment below. Thank you and see you next time. Bye.